Hello friends. Welcome back to my YouTube channel. In today's video, we're going to be talking about a really exciting topic that's been getting a lot of attention lately, edge computing. Now, if you're like most people, you might be thinking, what in the world is edge computing? Well, don't worry, because by the end of this video, you're going to have a clear understanding of what it is and why it's important. So, first things first, what is edge computing? In a nutshell, edge computing refers to a way of processing data that's done closer to the source of the data, rather than sending it all the way to a centralized server or data center. This means that instead of having all of your data stored in one place and having to send it back and forth across long distances, you can process it right where it's being generated, which can save time, reduce latency, and improve overall efficiency. Now, you might be wondering, why is this such a big deal? Well, there are a few reasons. First of all, as we continue to generate more and more data, think about all the data that's being generated by the Internet of Things. For example, it's becoming increasingly impractical to send all of that data to a centralized location for processing. It's just too much data to handle, and it can be really slow and inefficient to do it that way. Secondly, as more and more applications move to the cloud, we're starting to see some issues with latency. Latency refers to the delay that can occur between when data is sent and when it's received and processed. When you're dealing with applications that require real-time processing, like self-driving cars or virtual reality applications, even a small amount of latency can be a big problem. By processing data at the edge, we can reduce latency and improve the overall performance of these applications. So, how does edge computing actually work? Well, the basic idea is that instead of sending data all the way to a centralized server, you process it closer to where it's being generated. This can be done in a few different ways. One approach is to use edge devices, which are small, low-power devices that can be placed closer to the source of the data. These devices can perform some basic processing on the data and then send it on to a centralized location for further processing, if necessary. Another approach is to use edge servers, which are more powerful than edge devices and can perform more complex processing tasks. Edge servers are usually located in data centers that are closer to the edge of the network, which can help to reduce latency and improve overall performance. There are also a few different architectures that can be used for edge computing. One approach is to use a fog computing architecture, which is a decentralized approach that involves using a network of edge devices and edge servers to process data. Another approach is to use a mobile edge computing architecture, which involves using mobile devices, like smartphones and tablets, to process data at the edge. So, what are some of the benefits of edge computing? Well, as we've already mentioned, it can help to reduce latency, improve performance, and save time and energy by processing data closer to where it's being generated. But there are also some other benefits to consider. For example, edge computing can help to improve security by keeping sensitive data closer to the source and reducing the risk of data breaches. It can also help to reduce costs by reducing the amount of data that needs to be transmitted over long distances. However, there are also some challenges that come with edge computing. For example, managing all of the edge devices and servers can be difficult, and there can be issues with interoperability and standardization. Additionally, there are concerns about data privacy and security, since sensitive data is being processed and stored at the edge, and there may be a greater risk of cyber attacks. Despite these challenges, edge computing is an incredibly promising technology that has the potential to transform the way we process and analyze data. So, if you're interested in technology and want to stay ahead of the curve, this is definitely a topic worth learning more about. Now that we've covered the basics of what edge computing is and why it's important, let's dive a little deeper into some of the technical details. First of all, let's talk about some of the key components of an edge computing system. The first component is the edge device. As we mentioned earlier, an edge device is a small, low-power device that can be placed closer to the source of the data. Edge devices can perform some basic processing on the data and then send it on to a centralized location for further processing, if necessary. Examples of edge devices include sensors, cameras, and other Internet of Things, IoT, devices. These devices are often located in remote or hard-to-reach locations, and they generate a lot of data. By processing this data at the edge, we can reduce the amount of data that needs to be sent to a centralized location, which can save time and energy. The second component of an edge computing system is the edge server. Edge servers are more powerful than edge devices and can perform more complex processing tasks. They are usually located in data centers that are closer to the edge of the network, which can help to reduce latency and improve overall performance. Edge servers can be used to perform tasks like real-time analytics, machine learning, and video processing. By processing data at the edge, we can also reduce the amount of data that needs to be transmitted back and forth between the edge and the centralized location, which can help to reduce latency and improve performance. Another key component of an edge computing system is the network. Edge computing relies on a fast and reliable network that can transmit data quickly and securely. This can be a challenge, since edge computing involves processing data across a distributed network of devices and servers. To address this challenge, edge computing often uses technologies like 5G, which can provide high-speed, low-latency connectivity. Now that we've covered some of the key components of an edge computing system, let's talk about some of the use cases and applications of this technology. One of the most promising applications of edge computing is in the field of autonomous vehicles. Self-driving cars rely on real-time data processing and analysis to make decisions about steering, braking, and acceleration. By processing this data at the edge, we can reduce latency and improve the overall performance of these vehicles. Another application of edge computing is in the field of industrial automation. Many manufacturing plants and factories rely on sensors and other IoT devices to monitor and control their operations. By processing this data at the edge, we can improve efficiency, reduce downtime, and save energy. Edge computing is also being used in the field of healthcare. For example, wearable devices like smartwatches and fitness trackers can collect data on a patient's heart rate, blood pressure, and other vital signs. By processing this data at the edge, we can provide real-time feedback to healthcare providers and improve the overall quality of care. In conclusion, edge computing is a technology that has the potential to transform the way we process and analyze data. By processing data at the edge, we can reduce latency, improve performance, and save time and energy. While there are certainly challenges to implementing edge computing, the benefits are clear, and this technology is definitely something worth paying attention to in the coming years. Thanks for watching, and I'll see you in the next video.